Okay, hello everybody, and welcome to the Immersive Visualization and Virtual Production session. In this session, we have 6 papers, and we will start with the first one. The first one, the presenter is Manolya Kavakli, and the paper is the Virtual Production Studio Concept and Emerging Game Challenger in Filmmaking. Let's do this.
I am Manolya Kavakli, Academic Director of IEEE Institute. In this paper, my co-author is Cinzia Cremona from Eva-Rae University. In this talk, our focus is the virtual production studio concept. After reviewing the current state of conceptual and technical research studies led by the industry, we will analyze significant trends in Australia and evaluate the impacts of this technology in filmmaking. Virtual production integrates virtual reality and augmented reality technologies with computer graphics and visual effects, using a game engine to enable on-set production crews to capture and unwrap scenes in real time. From this point of view, the virtual production concept is a game changer for the traditional film industry, which has typically a linear production line, comprising in an order pre-production, production, and post-production. Iteration in such an assembly line is challenging and costly. Now, you may think, what brings virtual production? Why now and not before? The real problem in filmmaking has been real-time processing of content at sufficient speed and with sufficient precision. As a solution, Epic Games led the development of the N-Display system using Unreal Engine to render 3D content simultaneously to multiple displays in real time. When we look at the history, we see that virtual production is not a new concept. Advancements for virtual production started with ILM and Vita in early 2000. We have seen examples of these in Lord of the Rings by Vita Digital, AI by Steven Spielberg, and Avatar by James Cameron. When we look at the current state of virtual production research, we see that there are academics predicting that in the next 10 to 15 years, complex movie sets will be digitally created for actors to give live performance in them. There are also academics such as Bennett and Ilmaranta stating that these improvements can facilitate actors' immersion and possibly have a positive effect on their performance, as there is a dynamic interaction between an actor and its environment established by inactive presence. Technical and industry-led research so far has focused on lighting, ray tracing, rendering, vision algorithms, deep learning, and AI, with a few publications only published by Visual Effects Society. Today, there are probably 250 LED stages around the world now due to mass acceleration because of COVID. Among these, we will name a few. Disney's ILM, for example, used virtual production in Mandalorian series, Hive Division in Italy, and in Melbourne, Dream Screen in partnership with Method Studios, in Adelaide, Rising Sun Pictures, with Eva-Rae and Novatech partnership. We have observed 3 major trends in this domain. The first one is globalization, with major studios setting up offices and facilities internationally, partnering with tech companies, acquiring more specialized studios to create distributed networks. The examples of these are seen with ILM opening an office in Fox Studios and Animal Logic Studio in Vancouver and LA. The second trend is the collaboration between virtual production and educational institutions. We have seen examples of these with Rising Sun Pictures with University of South Australia, Animal Logic with UTS, Sydney, and Becca Entertainment with Deakin University's Motion Lab. Basic Pacific Bay Resort Studios and Village in Coffs Harbour also collaborated with Australian Television and Radio School and Australian Academy of Cinema and Television Arts. The third trend that we have seen is the industrialization, with the growth in the number of hybrid companies that gather under the same ownership, such as NEP acquiring Lux Machina, Halon and Prism Collective, Netflix purchasing Albuquerque Studios, and so on. Why is this happening? So, virtual production technology blends real with virtual, i.e. physical and virtual production. More flexible pipelines and workflows emerge, and this reduces iterations. Digital assets created for one film can be deployed and reused. Digital data can be distributed across networks of studios, allowing parallel processing, which in turn reduces the costs of production. LED walls immersing actors from inform their live performance and may positively affect their acting skills. Using screens as a lighting source, on-set reflections are captured on shiny objects. Directors gain better control on the production with the ability to click and drag to change scenery and lighting. Using mixed reality, the final broadcast can creatively mix pixels from the physical and virtual cameras. And VP reduces the need for filming in real locations and eliminates the travel costs, giving also full control on lighting and climate conditions. So after seeing all these benefits, we can suggest that VPS technology suggests a paradigm change in filmmaking. There is a need for an integrated VPS network in Australia through shared infrastructure and resources and collaborative research partnerships. And in future, we believe that low-budget small productions will have an opportunity to be released with the virtual production technology, and it is important to build a set of cutting-edge skills to be relevant on the world stage. However, AIE is the only organization that has been planning to offer short courses for professionals in the vocational space and AIE Institute in the higher education. Thank you.
Thank you, Manolya. Let's move for the second presenter. I just would like to remember the audience that we are waiting for the questions in Discord, mainly in Discord. And please, if you have any question, add there in the session Immersive Visualization and Virtual Production. Okay, the second speaker will be Danielle Lottridge, and the paper is Exploring the Design Space for Immersive Embodiment in Dance. Go ahead.
My name is Danielle Lottridge from Computer Science at the University of Auckland, and I will present to you our work on exploring the design space for immersive embodiment in dance. A nod to my colleagues, joint first author Becca Weber from Dance Studies, Ray McLean and Hazel Williams from Software Engineering, Joanna Cook also from Dance Studies, and Huidong Bai from the Auckland Bioengineering Institute. So when you hear immersive embodiment, I am imagining one of the first things that comes to mind is an avatar, but we are taking a different focus in this work on our own human bodies within virtual environment. And we ask, how can we better understand factors that impact embodied dance experiences in immersive environments? And what are design opportunities for responsive VR for dance? To start to look at these questions, we take an action research approach. Action research is an iterative, practical approach where you have research questions like we do, and then you iteratively try to understand the space, build prototypes, evaluate how those prototypes work, what you find out with them, and then iteratively re-prototype and retest. Let me take you through what we did and what we found out. In our first workshop, we used some popular existing platforms that could support embodiment. We had Beat Saber, O-Shape, Tilt Brush for 3D art, and we invited our participants to mix and remix together different experiences that they found compelling and embodied. One first example is creating virtual artifacts and then dancing with those artifacts. In another example, we see an asymmetric collaboration where one dancer uses fabric in real life and the other creates arcs in 3D art. Our other workshops went through 360 video, multiplayer 3D art, 360 point cloud. We had contact dance, where dancers were focusing on the sensation in their bodies as mismatched from the perception in their eyes. We had remote collaboration and choreographic collaboration that was co-located, though with one participant looking in VR and the other person dancing in the space. Workshops 1 to 4 were conducted in person, and the last workshop was held online. For our last workshop, we had iteratively built some immersive scenes, and so I'll take you through the different immersive scenes that we had. First, we start with responsive visuals that were external to the body. So that's what you see here, where different groups of rectangles correspond to the different body parts and move with the velocity of sensors in the motion capture suit. Our next scene was an immersive terrain scene where the user glides through the scene and influences the shape of the terrain right beside them. If they look behind, they can see the shapes that they've influenced by their movement. We had 2 scenes that focused on responsive sound. The first had sounds triggered by sudden deceleration in movement of certain body parts, and the other had gradual changes. Our last set of scenes were around particles, and these were the most exciting and enabled participants to feel the most embodied. I'll take you behind the scenes to our dashboard to see how these different particle effects can be created with various kinds of parameters. Participants felt the various kinds of particles in different ways, such as light or heavy, and they were interested that it made the movement seem different to them. In our future work, we're very excited to pursue this, to see how different kinds of parameters of the particles might affect our perception and sensory awareness of our own movement, as well as affecting the movements that we spontaneously make. Reflecting on our 5 action research workshops led us to create a design space for immersive embodiment in dance with 4 axes. The first is to support a range of control from abstract to direct. Our participants were very interested in the direct control, where they saw a relationship between body movement and a visual. They were also interested in the abstract relationships. It led them to be curious, to understand how were these things related. They like to see those relationships unfold. The second is to support multiple forms of collaboration. Over the course of 5 workshops, we saw different forms of collaboration, always bringing new motivation, new interest. For real-time visual effects, relationship to the body helped support embodiment. If it was co-located by the body, like the particles leaving the limbs, or further away from the body, like the terrain. So we had the gradual effects that would match something like distance from the ground, or overall speed and volume, or more triggered sounds where the fast deceleration of a particular punch movement, for example, could create a chord. These are some factors that will help researchers support embodiment in virtual reality. Thanks for listening.
Okay, thank you, Danielle. Let's move to the next paper. And for the next paper, the presenter is Noel Park. We can charge our presentation. And just remembering everybody that questions should be added in Discord. Yeah, it's with you. We are not listening to you, Noel.
Hello? Hello?
No, it's okay. Please go ahead.
So do I start from the beginning? Yeah, okay. Hello everyone, my name is Noel Park, and this is our paper presentation on mixed reality co-design for Indigenous culture preservation and continuation. So our paper is based on the overarching RTF business project, and the main question we're trying to answer is how can we digitally connect Maori back to their cultural roots using immersive technologies? So Maori are the Indigenous people of New Zealand, and many of the cultural practices occurs at what's called a marae, which is the cultural meeting place. And these are generally located throughout rural places throughout New Zealand. And what we're trying to do is create an application to support these cultural practices and also to bring Maori back to their home, especially during the COVID situation. So we're aiming to achieve this by recreating the marae space. As you can see here, this is the marae on the right image. Secondly, we want to support 3D storytelling because Maori have a very strong oral tradition. And then lastly, we ultimately want to support telepresence so that Maori can share their virtual marae space with their families in real time. So over 3 years, we've developed a strong trust and relationship with our Maori partners down in Bluff. So Bluff is located in the most southern part of New Zealand, located in this red dot. And during that process, during the co-design process, we stick to 5 major guidelines to form a successful partnership. So the first one being is to be culturally involved. So when we first arrived, they have something called a pōwhiri, which is the welcome ceremony. Secondly, we reciprocated their hospitality and gesture by inviting them back to Dunedin and showing them the cool technology that we're developing. Thirdly, we work towards small iterative tangible outcomes so that it produces more space for discussions and feedback from our Maori partners. And then we took cultural precedence over technical or academic objectives. And then finally, we asked for permission if we were ever unsure about anything. So as first part of our application development, we reconstructed what's called a wharenui. So wharenui is one of the key buildings in the marae complex. And this building is very important because within the wharenui are all these colorful carved wooden panels, and which contains all the histories and stories of that tribe. Additionally, we also had one of the Marae leaders getting involved with recording the stories in 3D. So here we see one of the Marae leaders talking about this wall, and this is being captured in 3D. With all those components, we developed it into this current application. And here you can see the user looking around and hearing Baba, which is the Marae leader, talking about that wall. So with the current application, we conduct the study. So the motivation for the study is first to explore the tikanga or the Maori protocols that are used or applied in this application. And then lastly, there's a lack of course, a link between VR concepts and Maori protocols. So how do we find this out? So of course, this is being such a new application area for this culture. It was hard to find standardized questionnaires or any use of quantitative analysis methods. So what we did was took an inductive approach and used qualitative methods, and we conducted interviews and then performed thematic analysis on those transcripts. So from the interview transcripts, we came up with we summarized them into three key themes. One being Tika Maori, so the Maori protocols, transfer of knowledge, and the VR experiences. Oops, sorry. So as an example, on the right we have, on the right we have some extracts from the transcripts and how it relates back to the sub-theme and relates to the key theme. So for example, the mana, which is the authority of the person. The authority doesn't come with the reference on the piece of paper. It comes with the knowledge of the person standing there with the mana authority. So being able to see that person, being able to see the authority, see them carry out their role as rangatira, chief or leader, and as a tohunga expert to transfer their knowledge is very important. So from those themes, we derived three new concepts. One being the sense of presence allows Maori to feel connected to their home. Secondly, the sense of co-presence supports all the social protocols, the list below. And then lastly, both the sense of presence and co-presence experience strengthens the fires of occupation or ahika as an increased sense of security towards their culture preservation and continuation. So the key take-home messages for this presentation from the paper are a participatory co-design process is useful for working with Indigenous groups. Our approach could also benefit other Indigenous projects with of similar nature. And finally, employing quantitative methods are useful for exploring Indigenous responses to emerging technologies, especially when there are no prior concepts established. Currently, we're working towards implementing the tele-co-presence feature. And here we have two individuals or two users sharing the same space, listening to one of the Marae leaders talking, giving a story about one of the walls. And currently we're doing tests between, the example you see here is actually a local test, but currently we are testing between the University of Canterbury and University of Otago for real lifetime, across real geographic distances. So thanks for listening. And if you have questions, feel free to ask in the Discord.
Thank you, Noel. Let's move to the next presenter. And the next paper will be presented by Huidong. And the paper is the timetables and embodied exploration of immersive spatial temporal data.
Hi, everyone. I'm Huidong, and in this presentation, I'm going to talk about our system timetables. So this work is a collaboration with Ernst, Kavakli, and Prozo, and Sarah Goodwin. So I'll first start with the spatial temporal data exploration. So this figure shows a map of a university campus, and a campus like that could have a lot of data, such as energy consumption data, weather data, which constantly change over time. And it is important and useful to get information from this kind of data. And a commonly used technique for visualizing spatial temporal data is space-time cube, which is to show the space horizontally and time is represented vertically. So due to its 3D nature, the visualization could be more intuitive and readable when moving it into the immersive environment. And using embodiment could make the exploration more process more engaging and flexible. So here comes our motivation, which is to develop a system to support spatial temporal data exploration using embodiment in the virtual environment. So we identified 5 design criteria for such system, and I'll explain one by one. First one is to support drilling down in time, and this is motivated by the uplift system. This example shows a space-time cube in AR representing daily energy consumption data, and users can shift to a more detailed hourly view by moving a tangible widget. Well, in our system, we would like to use embodiment to support drilling down the temporal data. Why using embodiment? This is inspired by Immersive, where users can directly manipulate the data representations, the virtual axis. This could provide users a highly engaging experience during the analysis process. And our next criteria is to provide multiple views. The previous work allows users to place multiple view maps around themselves. However, we apply this principle to time rather than space. And the system should also support full use of the virtual space. The data hub takes advantage of a large virtual space to arrange different data views that are created during the analysis process. We extend this concept by making use of available space over tabletops and on wall surfaces. The last criteria is to support multiple physical skills. This is motivated by recent work that has explored the use of physical skills. And the tabletop scale should be included to provide a broad view, and the large scale can be added to immerse users into the visualizations. So based on our motivations and design criteria, we developed the prototype system timetables. So the system consists of a large room scale space, 2D maps on 4 storage walls, tabletops and pedestals with space-time cube visualizations above. And most elements of our system can be manipulated directly. Users can move the tabletop around the space or onto the storage wall. And building models on the tabletops can be picked up for more detailed information. A block represents the data of a single building at a certain time frame, and a layer shows the data of multiple buildings at the same time period. Both the block and the layer can be arranged using direct manipulation. So for drilling down in time, users can make a copy of the targeting layer and create a new tabletop, and then stretch the layer to get a more detailed time granularity view. Similar to the layer, user can make a copy of a single block and create a pedestal, and then stretch the block to drill down in time. So the levels of the time granularity in our system include yearly, monthly, weekly, daily, and hourly. So this figure shows the data in different time granularity and users are able to compare the data presented on the multiple pedestals. And this also reflects multiple views provided in our system. So more detailedly, each tabletop is a compass view, and different tabletops are for different time granularity views. And pedestal is single building view for different time instances. We also have wall view of 2D maps for the stored visualizations. Well, when doing complex tasks, the space is easily to get full occupied. Therefore, we provide users the ability to store the tabletop onto the wall and get it back when needed. And we also allow users to transfer between the visualization scales of a tabletop and a large map by jumping into and out of the tabletop. So within the large scale map, users can open a minimap and use the InvisiBox to explore the buildings that are excluded. And users can also teleport on the map to get a more immersive experience. So we present a use case scenario to describe how people can conduct data exploration and analysis tasks using our system. For example, people can compare the data of one building at several different time periods and compare the data of two buildings at the same time period, and then can stretch each building for more detailed temporal data. The use of embodiment is easy and flexible for comparing the data. So the current system is easy to get messy when doing complex analysis. So we would like to further explore the concept of embodied provenance to support history tracking using embodiment. This could include the ability to undo, redo grouping visualizations that are comparable using landmarks or automatically placing. To summarize, our main takeaways are the timetable system and 5 design criteria to support embodied exploration of spatial temporal data. We also identified several potential improvements over previous implementations and look forward to continuing these explorations in the future work. Thank you for listening.
Thank you very much, Ida. It was a nice paper. Let's move to the next one. And the next paper is a TVCG invited paper. And it will be presented by UX Carbas. The paper is the virtual replicas of real places, experimental investigations. Let's go.
I'm presenting this work on behalf of my colleagues at Virginia Tech. Before we go any further, I want to warn you that I am going to cover this work at a very high level. There will be no numbers and no graphs. If you want those, please consult the paper. With that said, let's jump right in. There are a great many applications of virtual reality that involve the creation of virtual replicas of real places, be they past, present, or future. Some of those are listed on the slide. In this work, we were interested in determining how accurate replicated spaces need to be in order for users to believe that they represent a real place. After all, a pixel-perfect recreation may not be possible or practical. Even something as mundane as constructing a detailed computer model of a room that actually exists is non-trivial. Manual modeling requires substantial human skill and effort, and even state-of-the-art scanning and reconstruction techniques are imperfect. In any case, the process of recreating the space will introduce errors. That said, it is certainly the case that users will consider some errors more noticeable, distracting, or implausible than others. Our goal was to generate some data and some knowledge about which errors were more obvious than others. So for this research, we saved a full-size actual room with furnishings typical of a living room. We also added clutter to many of the horizontal surfaces of the room, such that they would represent a real living room setting. In all, there were just over 100 items in the room. In order to investigate which changes were most important to participants, modified replica rooms were created by changing several parameters of the most accurate replica, or MAR room, as seen in the right image. A photograph of the real room is in the image at left. First, we conducted a pilot observational study where participants each experienced a series of modified rooms and were asked to think aloud as they explored the rooms. We then analyzed their comments and identified several reality parameters that could be used for further investigation. So the reality parameters that were used in the subsequent studies were room scale, expressed as a ratio of the size of the real room to the virtual room, furniture scale, expressed in the same way, furniture elevation, expressed as the number of centimeters above or below the veridical location. This could be modified to make objects either seem to float in the air or sink into their surroundings. Elevation of clutter objects, expressed in the same way. The number of clutter objects from 0 to the maximum number, and lighting. In this experiment, there were 3 lights that could be toggled on or off. There were the desk lamps, which were represented as point lights, the sun outside the room, which was represented as directional light, or the ceiling light that cannot be seen in these pictures, unfortunately, but it was there. We then conducted a traditional psychophysical study with 8 participants and 210 trials per participant. In each trial, participants first experienced the MAR room and then experienced an exposure room where one of the reality parameters was modified and were asked to report on a scale from 1 to 7 how different that room felt from the MAR room. Finally, participants experienced a test room where they were asked to modify one of the parameters until it felt as different as the exposure room had. And finally, we conducted a so-called budget-based psychophysical study. By budget-based, we mean that we employed a variation of the method pioneered in VR by Slater et al. In the paper Visual Realism Enhances Realistic Response in an Immersive Virtual Environment. Here, participants were placed into a series of virtual rooms in which the reality parameters were reduced, and then were given an improvement budget that they could spend to make the room feel as realistic as they could. Dependent variables here were 1, the sequence in which the reality parameters were modified, 2, the value at which each parameter was finally set, and 3, a post-experiment ranking of parameter importance. And with that, let's jump into the results, which, again, at a high level, were that scale matters a lot. The 2 most important reality parameters were room scale and furniture scale. And the relationship is also very important, but not by itself, because in virtual reality, there's also the implied scale provided by one's own body. So it's not sufficient to have a perfect relative scale that is perhaps a dollhouse or a giant world, because that would present as strange to a real user. We also found that physically implausible configurations, such as objects floating or sinking into the floor, were rejected. Median expenditure to improve the clutter height was 25 out of a possible 25, indicating that in a majority of trials, participants chose to spend their budget to remove all error from clutter elevation. An error of even 1 or 2 centimeters was seen to be very disturbing. And finally, we observed that lighting had little or no impact on users' feeling of reality in this study. Why is that? It could be that we're used to lighting changes from the real world. Lighting is not necessarily part of a stable world model. We don't perceive the world to be more or less realistic as its lighting changes. It might be that the computer graphics techniques we employed in this study were not up to the task. And they might also be that lighting conditions in the real world did not correspond to the available options. So, for example, there was only 1 angle of sunlight available in the virtual world, which might not have corresponded to the way the room was actually lit when participants experienced it. So, as take-home messages, I'd like to just state that the scale of large objects In this case, the room shell itself and the furniture inside of it were the most important factors for the space to feel real. Plausibility, in terms of avoiding objects floating or seeming to interpenetrate one another, was also important. While the number of clutter objects did not seem to matter very much, and lighting conditions in this study did not seem to matter at all. Thank you very much for your attention. I'll be happy to take questions at the end of this session. Thank you. Bye.
Thank you, Rick. And let's move to the last presentation. And the presenter is Huidong. And this is a journal paper. And the paper is a virtual cube and immersive 3D video communication system. Please go ahead.
Hello, everyone. I'm Huidong from Microsoft Research Asia. I will give this presentation together with Jiaolong Yang. In this paper, we present Virtual Cube, an immersive 3D video communication system. The goal of our system is to enable people in different places to meet with each other as if they were in the same room. While a lot of work has been done towards this goal, there are still many challenges that remain. Our goal is to push the state-of-the-art one step further. Our key idea is to map all users into one shared virtual environment and display all remote participants in life size from the local user's viewpoint, as if seeing people through the screen. In this way, eye gaze and all other interactions between participants are naturally preserved. To this end, we designed Virtual Cube, a standard cubicle equipped with 6 RGBD cameras and 3 displays. The 6 cameras are used for capturing the local participants' 3D video. The large format display gives the user an immersive experience by displaying the environment and other participants at life size. Our system consists of 2 key components: VCube assembly, which brings all virtual cubes into the same environment for various meeting scenarios, and VCube view, which synthesizes life-size portrait images. Now I will introduce how VCube assembly works. We take 2 users, for example. Each user is sitting in their own cube. We map each virtual cube into a global coordinate system according to the meeting scenario. In this way, we transform the remote user to the coordinate system of local user. Various meeting scenarios can be produced by a different VCube assembly, such as a face-to-face meeting, side-by-side meeting, or a roundtable 3-person meeting. In this way, our virtual cube can serve as a basic building block for diverse teleconferencing scenarios. To our knowledge, this cannot be achieved by previous systems. Next, Jiaolong will present the VCube view rendering algorithm.
Okay. Given the RGBD images captured from multiple viewpoints, our VCube view is to synthesize the portrait image of the user from a new target viewpoint. This portrait image will be displayed on the remote user's side. There are several key challenges for realistic human rendering. We need to faithfully render nuanced facial expressions and handle the complex non-diverging surfaces. Besides, the life-size rendering must be performed in real time under reasonable hardware requirements. To our knowledge, no existing solution can solve all these challenges. The conventional systems often produce blurry and broken faces, and we want much higher quality. So we develop a new solution for portrait image rendering. One key innovation is that we estimate the geometry of the user very efficiently and use this geometry as a proxy to support our neural looming graph rendering using the sampled light field data. Another key ingredient is that we apply image enhancement based on state-of-the-art deep image processing techniques to further improve the rendering quality. So Given the multi-view images captured by the cameras, we first estimate the depth map at the virtual target viewpoint. The estimated depth and texture are significantly better than naively fusing the multi-view Kinect depth. However, the texture quality is still quite low. So to make best use of the sampled light field data from our multi-view cameras, we use the depth map as geometry proxy and follow several principles of unstructured lumograph rendering for determining the texture blending weights. But a key difference to the conventional lumograph rendering method is that we do not use empirically chosen formula. Instead, we bake all these principles into an end-to-end neural network learning process for fast and optimized blending weight prediction. More details can be found in our paper. As we can see, the result is further improved by a large margin using lumograph rendering method. Finally, we enhance the rendering results by applying state-of-the-art deep image processing techniques. We primarily focus on the facial region and apply several techniques such as perception-based optimization and adversarial learning to train a CNN. As we can see here, the result is further improved compared to LumiNet rendering. It is now quite close to the ground truth. So with all these components, we bring users from different virtual cubes together as if they are face-to-face. So our system runs on a combined CPU and GPU platform. Next, we'll show 3 demos. The first demo shows a face-to-face meeting scenario.
Hi, Lisa. How are you doing?
I'm good. How about you?
Oh, I am doing great. I want to take this time to discuss project plan with you. Have you seen it?
Yes, I did yesterday. Overall, it looks good.
The second demo shows a group meeting scenario among 3 users. As you will see, the users can naturally talk to each other and pay attention to each other when different users talk.
Well, Lisa, so is the UI optimization the part we have discussed last time?
Oh, yes, it is. But unfortunately, I cannot find an expert from my team to fix the optimization.
I see. Well, I think maybe I can help. Let me check with Mike first, okay?
Oh, okay.
As you can see, these 2 participants are naturally having a side conversation as if they were in the same room.
Okay, in the last demo, we show a side-by-side working scenario.
Hi, Jack. I'm just working on it. I need a picture of our product. Do you have it?
Yes, I do. Let me find it. Okay, let me copy it to you. All right.
It looks great.
So to conclude, the virtual cube system advances the state-of-the-art of large format video conferencing. It is standardized and simplified, all using off-the-shelf hardware. It can render a high-quality human portrait in real time by the VCube view algorithm. Furthermore, virtual cubes can be easily assembled into different meeting scenarios by VCube assembly. For more technical details and complete demo videos, please go to our website. Thank you.
Thank you. First of all, I would like to thank all the presenters. And let's move to the Q&A. We don't have many time. We have 11 minutes for this. I will try to do at least 1 question for each. And the first question is for Manolya. And the question is, from what I saw, it was made by Huidong. From what I saw from news about virtual production, the actors are in the front and the scene is on the LED screen on the back. It seems the actors and the scene are separated, will cause the virtual production unable to be as real as traditional films, where the actors are actually acting in the real world. Is it okay? We are not listening to you.
Can you hear me now?
Yes.
Okay, excellent. Yes.
Oops. Yeah, but there is an echo.
Turn your
There
sound up.
is- No, no sound.
Try again.
The same,
Sorry,
noisy.
it's just the echo is too much. Can you hear us now?
With there is an echo.
Maybe we talk from. Okay, try. No, it's not gonna work.
Yeah, perhaps you can move to the next one. If you can fix this, just make a sign and you can move to you again. Okay, the next question is for Danielle. And the question was made by Rick Scarbets. And is there intention or interest to use these techniques as a performance medium in their own right? Thoughts about how that might work?
Yeah, so we sort of collectively with the project goal wanted to involve sort of audience members or just general people in the experience. But yes, we're sort of creating this or co-creating this audio visual mixed reality artifact, and we think we might as well create a production with it. But yes, we're still figuring out how that might work.
I have just a curiosity. Are you recording all the movements, and you can perhaps make a visual track of the movements?
Yeah. So actually, so we were using a neuron perception motion capture suit, and in our sort of over the course of 5 workshops, we were in New Zealand where there was no COVID for quite some time. And so we had collected that data during the 4th workshop, and then sort of lo and behold, slipped in through the border. And we used those pre-recorded dance movements to sort of try out all these different, or like to sort of simulate what the audio and particles would be with these pre-recorded movements. And so, yes, we do have that. Okay. And so, yeah, thinking about like dancing with, a past dance movement, like there's so many possibilities of coupling that together.
Okay, thank you, Danielle.
Yeah.
We can perhaps try again with the first presenter. I don't know. Do you arrive, Manolya?
Sorry, we just have a terrible echo.
Now, we think we have Zoom running in more than one machine in the same room.
We do. We have to.
One, it should work. Because we are listening your voice from the other machine. Okay, let's move to the third one. There is still time to come back. And the next question is for Noel. Yeah, Noel Park. And it was made by Nikki Cartledge. And the question is there opportunity within the guidelines for this to be used to help educate others about Maori culture?
Hello. Oh, there we go. It's still working. That's a very interesting question. I would say yes, because ultimately, when you're dealing with when you're trying to develop something for others to learn about Maori culture or even any other culture, you'll be involved with a Maori partner. So following these guidelines would be most applicable, because ultimately what you want is a good, strong partnership where you can trust each other, and then they will teach you what is the correct way to teach their culture. So yes, I believe it is useful.
Okay, and the next question is it's also for you. Yeah. It's from Rick Scarbus. It's great work, very important. Did you have any occasions where something you implemented ended up not being aligned with the community's needs, and how did you work through that disagreement?
Okay. Yes. So I guess we were lucky that we haven't had many major disagreements. But what you have to realize is the whole project is a Maori-driven project. So ultimately, what they say and what they disagree with, it is their last call, basically. So you have to kind of listen to what they say within your technological limitations, I guess. Yeah. So for instance, there was a case earlier when we recorded a high resolution recording of one of the Maori speakers down in Dunedin, but they was only represented as a bust, and they did not like it because for them the head is very important, and serving that bust on a pedestal basically as like a museum kind of animated talking element, they didn't like it. So I mean, fair enough, we just listened and we just removed it. Yeah, you just need to listen and compromise, really.
And they had no concerns regarding technology? This is another question here from Horace. They
had no concerns?
Yeah.
Oh, right, okay. Right. No. Yeah, that's a very unfortunate part, because I expected, for them to actually say some disagreements, but mostly the system was received very positively. And actually, in most cases, you have a lot of emotional responses when they use the system. So, for example, I brought one of the people that are affiliated to that place, but haven't been back home in very long time. And when they tried that on and then they took it off, I saw them crying because they were like, they had the sense of awe, and they're very compelled by the experience of being home.
Okay, thank you very much. I think, Manolya, the issues were fixed. Do you still remember the question, or I can do again? I think, no, we are not listening to you. No sound. Sorry, you have no sound. Still. No sound. No, we're not listening to you. No. Okay, let's go one more, and we have still time to go back. Okay, and next question is for the timetables for Eden, and it was from Martin Pratt. This looks great. It seems a really nice way of exploring spatial and temporal data when the spatial data is 2D. Have you thoughts about how this could possibly extend to 3D? Say, for example, if you had data from all the rooms in a building on multiple floors that were changing over time. This is a question.
Yeah, I think this is a good point. Actually, for our current space-time visualization, it may not suitable for represent the space in 3D. Like in our model, the space is represented horizontally, so only on the horizontal plates. But yeah, actually, just a good direction to think about if we could like combine with other types of visualization that we could also present the space in a 3D thing. Yeah.
Yes, because you have an additional dimension. Okay, the other
So
question.
actually, we could place the layers vertically, so that could properly make the space more 3D a bit, but really more to think about this.
Okay, next question is from Georgie Wagner. And congratulations on this interesting implementation, integrating several concepts for immersive data exploration. Are you planning a user study as a continuation of this work? It will be interesting to analyze how users leverage these different forms of interaction for different tasks.
Yes, a user study was what we initially planned, but unfortunately, due to the COVID situation, we didn't have a chance to do a user study. But definitely, we will plan to do some evaluation with the users in the future when we're allowed to do that.
Okay, thank you.
Thank you.
Let's try the first again.
Hi again. So can you hear us? Okay, good.
Working.
At least fixed the issue. So can I just get the question again, please?
Yeah, of course, of course. And the question from Lingwei Tong. From what I saw from news about virtual production, the actors are in the front and the scene is on the LED screen on the back. It seems the actors and the scene are separated. Will cause the virtual production unable to be as real as traditional films where the actors are actually acting in the real world.
Yes, so that's the promise of virtual production technology. So at the moment, I think the major problem is the real-time processing, and just like in the headsets, the same problem appears in the immersive visualization here as well. So how good the processing is and how quickly we can process the images at the background as we move, as the actors move within that space. So that is the key issue. At the moment, the real-time processing is trying to solve this. So currently, they can only highlight partially the screen, so not the full lot. So when the actors, of course, too quickly move, the synchronization may not happen as easily as we would like to see. So there are still issues, but yes, basically the promise is that. I think in future, probably, the film sets will be replaced with the digital ones.
I also want to add that the LED screen is not flat behind the actors. These days there are LED volumes. In fact, they're called volumes. So some of them are curved and some of them have 3 sides, but you can also have the ceiling and it can be integrated with green screen and with projection. So the actors are immersed to quite a good level. And already, I think it was in Avatar or the Jungle Book, actually the actors can see what they're interacting with. They can see themselves in the helicopter or on the branch of the tree in the screen. So there is that sense of immersion as well. So on 2 levels, it's already working. But yes, some technical problems still have to be refined.
Beyond the technical problems also, there is another advantage because of the reflections also can be seen within the objects inside the immersive volume. It also presents another advantage of the virtual production technology as opposed to green screen technology.
Okay, thank you very much. We have here a lot of questions, and unfortunately our time is finishing. I tried to do some few still for the missing ones, and the next one is Ricky. Rick, great talk. I really enjoyed it. Do you think that representing the same number of furnitures or objects can be an important factor as well?
Yes, that's absolutely the case, and further information on that is in the Discord chat. But the reason that it wasn't explored further is that it was perceived by everyone all the time. So we've decided that there was no sense collecting further experimental data, because when there are only half a dozen or so large objects, when you take one of them out of the room, it substantially changes the feel of the room.
Okay, and we have another question regarding the scale. Did the scale matter more if the objects were smaller or larger than the real? Or was it just what they were different?
It both ways. So the room was perceived to be much stranger, much more different when it was smaller than it should be. So when it was smaller than a normal room, when it passed some threshold of acceptable smallness for a room, whereas when it got larger, that was not perceived as different. When it came to the furniture objects, though, that scale difference was roughly symmetrical. It was perceived as different whether the furniture was smaller or larger than it should be.
Okay, thank you. We also have a question for Huidong. It's regarding VCube. Can you compare against Google Project Starline? And this is a question from Muhammad Uzaifa.
Yeah, sure. Thanks for the question. There are some differences between our system and Google Starline. The first one is that Google Starline has a complex imaging system, and ours have a simple camera configuration where we just use 6 RGB Air Kinect cameras. And the second is that Google Starline use auto stereoscopic display, and we use 3 normal displays to create a more immersive environment. But of course, we can also use that auto stereoscopic display as well. But the key difference is that, to our knowledge, Google Starline is mainly designed for one-to-one meeting between 2 sites, right? And for our virtual queue, a key idea is that we want to support diverse meeting scenarios, such as group meeting for multiple people and side-by-side working, which cannot be handled by any previous method, as we, to our knowledge. And we hope that virtual queue can be used as a basic building block to really support very different types of meeting. Yeah, that's a different goal to compare to Google Starline. Thank you.
Okay, thank you very much. Okay, it's so unfair that we need to finish the session. We are late, 8 minutes late, and I'm seeing that the authors are still answer the questions in Discord. Please keep doing this, can keep discussing, and go to Virbela to discuss a little bit more, and hope to see you in the next sessions. Thank you very much for all the authors, the presenters, and the audience here. Thank you, and have a good continuation.
Thank you very much, Luciana.
Thank you. Thank you for hosting this session.
Thank you so much.
Okay.
Thanks. Cheers.
Thank you. Bye-bye.
Thank you.
Thank you. Bye-bye.
Bye.